dai contenuti stessi, non vi faccio perdere tempo e passo subito la parola al presidente di Eutelsat, Giuliano Beretta.
Piacere, l'onore di aprire questa serie di conferenze e vorrei parlare in inglese considerando il numero di ospiti stranieri che ci sono qui presenti, e sono sicuro che gli altri capiscono tutto l'inglese, anche perché la mia società usa di solito l'inglese come lingua diciamo franca. So I will speak English, that's what I said. So you're wondering what Eutelsat is doing in a place like this, in a scientific community where today we're looking at something that opens perhaps a new way of using the frequencies. But Eutelsat is particularly concerned about the problem of frequency. Frequency are becoming a very scarce resource, and today we've been going up, particularly satellites, from L-band, the one that we see, S-band actually today, in experiment, C-band, 5 gigahertz, 6 gigahertz, 11, 12 gigahertz, 20, 30 gigahertz. We are going up and up with the frequency, but obviously we have some constraints because atmospheric perturbation create a problem. More and more you go up with the frequencies. We are trying to use the frequencies, of course. The two normal uses are the two polarization, vertical, horizontal, right-hand circular, left-hand circular. But we are also using other methods to increase the capability of a satellite using the same frequency spectrum. In particular, we have today launched a service, which is two-way, a Ka-sat satellite, where we're using, in 20-30 gigahertz, a multiple use of frequency, creating spots on the surface of the coverage area. So we are multiplying by 35 times the capability of a satellite. But this is what you can do with the normal means, with frequencies, polarization, and space discrimination by spots. Here, we are in front of something new, which will maybe be possible to use in a few years, because obviously all the technology must develop around it. But today, I think it's a breakthrough. If it works, it will be fantastic. So you know what is the place of Eutelsat here. We are particularly concerned, and I think we are in a specific advantageous position, because also our beams are very narrow. So if there is a perturbation due to the space opening of a beam, in satellite this will be less evident. So we might be the first application of this type of new opening, where instead of having only the vertical horizontal polarization, we will have other mode of transmission that we can call Mickey Mouse, Donald Duck, or whatever you want to do. So that is a new opening. Even if we had only one additional mode, and we could increase on 1/3 the utilization of the frequency, this would be a terrible breakthrough in our field. So I spoke just to explain to you the importance of this. It's not just to find another way of transmission. It's opening completely a new way of exploitation for a commercial operator like us. Incidentally, Eutelsat is the third world operator with 27 satellites in orbit, and we are the largest space operator in telecommunication space operator in Europe. So I will not speak anymore, but I wanted to show to you the importance of getting something that breaks the constraints in which we are today. And the reason why, when my friend Luca introduced me Tamburini, why I became immediately enthusiastic, and I came immediately to Venice, and I had a lunch with Professor Tilde and Mr. Tamburini here in Venice to discuss this opportunity, because I saw for us a new opening and a possibility of satellite to continue to increase the development. It is a pity that we couldn't show our two-way system. This is my publicity page, of course, because after the normal, I put the commercial, that you couldn't see it because I think it was difficult to show it here. But if you are living in the countryside and you don't have internet at high speed, today it is possible. Even if you want to live on top of the Mont Blanc you will have the internet thanks to two-way, thanks to GAISAT. Thank you very much.
Grazie al Presidente Beretta e adesso diamo la parola a Sir Michael Berry dell'Università di Bristol. Mr. Berry, speak.
We are celebrating a beautiful but rather strange experiment. It's beautiful, especially to me as a physicist, because your local astronomer, Fabrizio Tamburini, and his colleague Bortide from Sweden here, have invented a new way to transmit radio waves using a fundamental property of all waves. Now it's strange, because that property is this. It's a straight line between this palazzo Ducale and the faro across the canal opposite, a straight line on which the strength of the radio wave is 0. So what they're doing is, in a sense, they're transmitting radio using nothing. Now, of course, that nothing is surrounded by something, and it's a radio wave in the shape of a corkscrew, a wave vortex around which the energy of the radio wave is spiraling. Think of that next time you use a corkscrew to open a bottle of Valpolicella or Bardolino. Now we know that these spiraling waves are not unusual. They occur naturally, not just in radio, but in all kinds of waves. In the waves of the tides, in light waves, in sound waves, in the waves of, even in quantum physics waves. Waves of electrical activity in your heart. They all have these spiraling, strange lines of vortex. But when they occur naturally, they're curved, they're looped, they're tangled. As I'm speaking now, the sound waves in this room are filled with a forest of these vortex lines, threads of silence, racing past your ears too fast for you not to be able to hear them. Now, when we identified these wave vortices in Bristol, where I come from, nearly 40 years ago, this was also in radio waves. My colleague, my senior colleague, John Nye, was a glaciologist, and he was studying the ice that covers Antarctica. The only way to see down through the ice to the ground beneath was with radio waves, not these 12-centimeter radio waves that are being used today by Fabrizio and Bo, but long waves, waves 5 meters long, where the ice is transparent. Now, in the long and disorderly echo that came back from the bottom, from Antarctica, there were mysterious features. We didn't understand them. And to study them, he, my colleague, made a laboratory model in which he used sound waves, millimeter, tiny sound waves, instead of these big radio waves. And instead of Antarctica, he took some metal foil from the kitchen, crumpled it up, reflected the waves. And in this way, we could understand, we then collaborated to understand what was happening. And we realized that these waves were threaded with these lines of 0, these vortex lines. That was a great moment. We had a colleague who, out of cardboard, made an antenna rather like the one that's being used today for radio waves to demonstrate artificially in the laboratory one of these vortex lines, a straight one, instead of the complicated ones that we encountered naturally. Now, this was a new feature of waves, and of course we wondered if we could use it to get information. But we soon learned that these vortices are very delicate and sensitive things. They're too delicate and sensitive when they occur naturally to use in order to get images, for example, of the ground beneath the ice, which is what we really wanted. We could, and did, use them to work out, to measure how fast the ice is moving. It's about 1 centimetre a day. Of course, that's very important nowadays, all the discussion of climate change. But we missed something. And what we missed, and what we are celebrating here today, is that a vortex An artificially engineered one, like the one today, not the natural ones that we discovered, can provide a way to transmit information simultaneously with the usual channel that does not involve one of these vortices. Now, as a way of, it's been mentioned already, as a way of doubling the capacity of a single frequency information channel, this could be very useful. Well, as well as being a clever invention for radio, here in the land of Marconi, of course, it's very appropriate, this illustrates something fundamental about science. It's a collective as well as an individual creative activity. And different people have very different imaginations, so you can never predict how an idea will suddenly reappear. I'm delighted with this unexpected application of wave vortices, and I really congratulate you, Fabrizio, and you, Bo, on their invention. It's a great honour to be invited here to celebrate this demonstration this evening.